Good morning. Myself Mukunda from BTech Cybersecurity and IoT, third year, doing my CA2 project of explaining how to build your VPC and launch a web server in Amazon AWS. So, we are in this tutorial, we are going to uh, learn how to build our VPC and launch a web server. So, on Amazon, we are going to create an Amazon VPC, that is Amazon Virtual Private Cloud, that enables us to launch AWS resources into virtual network that we define. So after this lab, we will be able to create a VPC, create subnets, configure security groups, launch an EC2 instance into a VPC, and this will be our infrastructure which we are going to build with two subnets, private and public, uh, and two availability zones with internet gateway, public route table, and private routes with a security group. So let's go into the tutorial. So our first task is to create a VPC. So uh, in these Amazon services, we will search for VPC, and yes, so we will create a VPC here by clicking create VPC. We choose resources to create for VPC and more. And in the auto generate, we will give the project name as lab as per AWS informations, and IPv4 CIDR block being the same 10.0.0.0/16. Uh, in the IPv6 CIDR block, there's nothing to do, with the number of availability zones being giving 1, number of public subnets being 1 as well, uh, number of private subnets being 1 as well, and in the NAT gateway, choosing the number of availability zones in which we can create NAT gateways. So yeah, there is a note that there's a charge for each NAT gateway. So we will give here one availability zone, and we should customize subnet CIDR blocks as well. So yeah, if for the public subnet CIDR block, we shall give 10.0.0./24, and for the private we will be giving 1 and /24. So, and VPC endpoints being giving none. We will keep we will enable both DNS host names and resolution as it's already there. Um, so now in the preview we can configure the subnet names, lab subnet public one and private one. Our root tables being public and private. The network connections being lab IZW and public NAT. With that, we will give the create VPC, and we will wait until the VPC is being created. The NAT gateway will take a few minutes to activate, so we will wait until all the resources are created before proceeding to the next step. Anyways, once it is complete, we will view into the VPC. The wizard has provisioned a VPC with a public subnet and a private subnet in one availability zone with route tables for each subnet. It also created an internet gateway and a NAT gateway. So we will wait until then. As we can see, the NAT gateway is waiting to activate. And while viewing the VPC, we have to browse through the VPC console links that display the resource details. For example, when we choose subnet to view the subnet's details, we can choose route tables to choose route table details. Uh, this diagram summarizes the route tables, private and public. Anyways, uh, an internet. An internet gateway is a VPC resource that allows communication between EC2 instances in our PC and the internet. Uh, Also, the lab subnet public one is a has a CIDR block of 10.0.0/24, which means that it contains all the IP addresses starting with 10.0.0 into x dot x. The fact that the root table associated with this public subnet routes 0.0.0 slash 0 network traffic to the internet gateway is what makes it a public subnet. So yeah, VPC is being created, and as I told, the we can check the subnets and route tables here. So yeah, now we will create additional subnets. So yeah, we will move into the subnets in the left icon, and we will create a subnet, and in the VPC we will be selecting lab VPC uh, with the name being lab subnet public 2, and availability zone. We will select the second availability second, such as US East 1B here, Northeast Virginia, and the CIDR blocks we will be giving us 10.0.2 point 2 point, sorry, 10.0.2.0 slash 24, and yes, now we will no tags to be added. We will create the subnet, and the subnet is created. Now the second public subnet has been created. Now we will create a second private subnet as we did the public subnet earlier. So again, the subnet name being lab subnet private 2. Again, the availability zone reference being West East 1B. Uh, IP for VPC CIDR blocks being the same, and subnet CIDR block being 10.0.3.0 slash 24. We gave 0.2 in public subnet. So the subnet will have all IP addresses starting with 10.0.3 dot x we will be considering, and yeah, we will no tags to added. We will create the subnet again. So yeah, both of our subnets have been added. Now our another private subnet has been added. Now we go to the root table. Root table contains a set of rules called routes that are used to determine which network traffic is directed. Each subnet in a VPC must be associated with the root table. The root table controls the routing for the subnet. So yeah, after going to the root table, we will select the Yeah. So now we will select the lab RTP private one one a root table, and after selecting we go into the routes tab here, and we note that the destination 0.0.0/0 is set to target NAT X, NAT and stuff, which is XXX. This means the traffic destined for the internet will be sent to the NAT gateway. The NAT gateway will be then forward the traffic to the internet. So the route table is therefore being used to route traffic from private subnets. So going now we will go into the subnet associations, and now we will just edit these subnet associations, and being lab subnet private one already selected, we also select lab subnet private 2, and we will save the associations. This will configure the route table that is used by the public subnets, and now we will select the RTP public, and we will remove the private one from it, and again we go into the routes tab and we see that the 0.0.0 slash destination is set to target IGW and slash and stuff, which is an internet gateway. This means that the internet bound traffic will be sent straight to the internet via the internet gateway. So we will now associate the route table to the second public subnet we created. So we go to subnet associations, and we will edit the subnet associations again, and in this we will also select lab subnet public 2, and we will save the associations. So as this being done, now we have we have the task of creating a VPC security group. So in the left pane we will search for the security group option, and yeah, here is the security groups. We will create a security group now, and um, yeah, so we will give the web security group name as web security group, as let's see how the name is being suggested by. Yeah, so we have in web security group, and no description to be given, but we will give enable HTTP access and VPC info. We will select the lab VPC for here. Uh, in inbound rules, we will add a type which is okay. Let's say we will do HTTP here, and source, and for the source anywhere from IPv4. Description permit web requests, and that's it. We will create a create the security group. So we will use this security group in the next task when launching an Amazon EC2 instance. So now we will launch a web server instance. So we will go to the EC2 to launch the EC2 instance. So this is our next task, to launch a web server instance. In this task, we will launch an Amazon EC2 instance into the new VPC, and we will configure the instance to act as a web server. So as going into the EC2 console, we will launch an instance, and for name we will be giving web server 1, So yeah, when we name our instance, it creates a tag. AWS creates a tag and associates it with the instance. The tag is a key value pair. The key for this value pair is the name, and the value is the same name as we enter for the instance. And now we will also give the application and OS. I mean, basically the machine image, and so we will keep the default Amazon Linux as it's being fine. So, anyways, uh, the type of Amazon machine image like AMI we choose determines the operating system that will run on the EC2 instance that we are going to launch, and we have to choose the instance type as well, and that is fine with T2.micro. The instance type defines the hardware resources assigned to the instance. So into the key pair, um, we will give select walkie. So the walkie key pair we selected will allow us to connect to the instance via SSH after it has launched. Although you will not need to do that in this lab, but we are going to identify an existing key pair or create one. So choosing without proceeding when we launch an instance won't be fine. So choosing going to the network settings, uh, we will edit the network settings first and give the lab VPC again and subnet. We will give the public because we don't want the private one, and we will enable the auto sign and we will give the security group existing. Now we select the web security group here, and this security group will permit HTTP access to the instance with all. In the configuration storage section we will keep the default settings that will specify the root volume of the instance which will host the Amazon Linux REST operating system that we specified earlier. So that will run on SSD, that is GP3, hard drive that is GIV in size. We can alternatively change the things, but we will keep the default. So in the advanced settings, we will go to the bottom and we will type the code. So yeah, in the bash. So yeah, so we will type this code. So this script will run the root user permissions on the guest OS of the instance. It will run automatically when the instance launches for the first time. This script installs the web server, a database, a PHP, and the lab files, that is the PHP libraries, and then it downloads a PHP web application and on the web server. So at the bottom we will launch the instance. Uh, the launching instance has been successfully launched. So we are seeing the success message here, and now we will view the view all instances. Uh, we will wait until all the status checks are passed. So we will refresh the screen until then. So once this will happen, we will connect to the web server running on the EC2 instance. And so let's wait until then. So yeah, the instance checking is still being done. So this will help us with the web server. So yeah, we'll refresh once again. Yeah, so we see both the two of the two checks are passed. So this will connect to the web server running on the EC2 instance, and we will click on the web server one, which we are going to do it, and we will copy the public IPv4 address, and we will paste it on the another web page. And so we should be seeing the web page displaying AWS logo and Insta metadata values. Although I guess there's a problem here. Sorry, we will copy the public IPv4 DNS. So yeah, we will wait until the output is shown. I hope the network connection is fine. So opening it. I guess there's some problem with the web page deploying, but yes. So I have successfully created this infrastructure with our security group web server 1 and public subnets in the vulnerability zone with internet gateway and NAT gateway, and we have we did routing of the table as well. So yeah, thank you for the thank you, and we will submit the task.